So now I've got inches right now over hours, and I just got to convert that into miles instead over hours. So let's get rid of inches. So that means I got to multiply into feet first. So there are divide by the inches, so they cancel out. 12 inches down here, 1 foot up here. And then I want miles instead of inches. And I'm going to want miles in the numerator because my final answer is going to be miles and hours down here. So even though I wrote it like this, I'm actually going to invert it. There's 1 mile for every 5,280 feet.
Okay. That's a lot of conversions.
Well, yeah, but it is like I need to get across the street.
Okay.
I need to get across the street from revolutions per minute and 12 inches. Because that's, or 25 inches, that's all I have. So here's what I'm carrying. And when I get across the street, I need to be in miles per hour land. So I got to convert all these things across along the way. So mile or minutes into hours, you know, since minutes are down here, you're going to multiply by minutes and you want hours down here. So that's the first one. And that's all I did was take care of one thing at a time.
Okay.
I took care of get rid of the minutes, make it an hour. Done. So now I still have revolutions. I don't have any distance yet. Every 1 revolution is a distance. It's a circumference. Circumference, pi times the diameter. Well, that's why they gave me the diameter. So there's my pi times the diameter. And you know what? I just messed it up, didn't I?
It's 25.
And I put 2 times pi and 12. It's just pi times 25. I don't know why 12 is in my head, but pi times the diameter. So now I've got revolutions gone. And now I've got inches over hours. So now I just got to get rid of my inches and convert inches into miles, and hopefully getting rid of inches going to feet. And not everybody has even dealt with how many feet are in a mile. It really works a lot quicker if you have metric, but hey, that's just tens.
So
So, right.
got rid of what it's hard to see.
Okay, let's see here. So this is 480, and that's revolutions. Okay, and so here's the first thing. Minutes over minutes are going to reduce. Revolutions down here, revolutions, that's going to reduce. And as we walk, I want hours. I want hours down here. So that stays. Inches divided by inches reduce. Feet divided by feet reduce. So the only unit left up there is a mile. Miles. So miles in the numerator and hours are the only unit down here.
Sorry, how many feet did you say were in a mile?
5,280. 5,280 feet equal 1 mile.
Awesome. Okay. So then we would just kind of multiply across, correct?
Yeah, so we're gonna have 480 times 60 times 25 pi. That's it. The rest are ones. Over 1 times 12 times 5,280. And we're going to get a decimal.
Yeah. 46.711.
1.42 1.428 miles per hour.
Okay. Okay. I'm just double checking here.
Okay. Oh, hang on a minute. I think I forgot the 25.
I did something wrong.
I did forget my 25 right
I got 35.69991652.
here. Yeah. Let me see. And this is why I never like to rush through these things, but it's okay. I need to kind of just slow down, slow my roll. When I multiply, the exact answer is I get 720,000 still times pi over 63,360. So then if you reduce it in terms of pi, you get 125 pi over an 11, which is 35.6999, so 35.7 miles per hour. So about 35.7 miles per hour. Yeah, I forgot to put the 25 in my calculator right there.
Okay.
So taking all the given information, and the key was, what units were you given? You were given RPMs, revolutions every minute, and you were given a distance, and we had to convert those units into miles per hour.
I have another question. So
Yes.
how will you know if you're multiplying by 2 pi or if you're just going straight into converting it?
Okay. If the directions say, give me the exact answer. If it's the exact value, then you leave it in terms of pi. So the exact answer, you're not going to use a substitution. 3.14159 for pi. So whenever it says exact, you leave it in terms of pi. If it says round to the nearest 100th, 1,000, 4 decimal places, whatever it asks for, then you know you are substituting pi in, because the only way to round would be to use a decimal approximation for pi.
Because I know number 15, 115, my bad.
115?
Asking for angular. So angular speed, we get that by multiplying 2 pi times the revolutions per minute, correct?
Yes. And that's basically, if you have revolutions every minute, and what you want is you want to get rid of revolutions and you just want angular speed. So how many radians every minute? My final answer should be in radians over minute. That means I want to cancel the revolution.
Okay.
So that means I want radians on the top. Well, there's 2 pi radians every 1 minute.
Mhm.
So yeah, that's what, seeing, if you notice, first of all, I'm visual. So when you just said what you said, you multiply by 2 pi, I'm going, let me get back to you. I don't know. Because I got to see it.
Mhm.
What I'm looking for is that going to cause my bad? And you know what? I didn't mean that. I needed to see if I multiply, what I meant was down here, 2 pi radians every 1 revolution. The revolutions reduce, and I end up with just radians in the numerator over minutes in the denominator, which is what they're asking for.
Okay. Okay.
So that's why you just multiply by 2 pi. So the formula doesn't explain that you're actually multiplying by 2 pi radians for every 1 revolution. It just says you're multiplying by 2 pi. But it doesn't make the effort to say the units are giving you exactly what you want. Your units have to agree.
So
So instead of memorizing formulas for me, it's what do I need to end up with when I'm done? And that's how I choose what I'm going to multiply with and the formulas that I'm going to use to get there. And I really wish as a student, I would have approached it that way instead of trying to memorize a huge amount of formulas and not knowing which one to choose. Because I would just go, I don't know which one to pick. And I never thought about what do my units need to be.
okay. Okay. So we have to look at the units, and if the units want it in radians over time, then we multiply by the 2 pi. But if they want it on distance over time, we just kind of start going and converting.
Yeah,
Okay.
and
That
if they just wanted inches,
Mhm.
inches over minutes, we wouldn't have had to do all the extra.
Okay. Okay. That cleared it up a lot.
Yeah, and then the part B to 114,
Mhm.
you're actually starting over here. What did it say? 70 miles per hour.
Yeah.
So you're starting over here with 70, and they're asking what should this be over here.
Okay. So we're starting.
Everything else is going to be the same, but you're now solving for this.
To 70 miles. Oh, I put 2.
So this would 70 miles every hour is equal to, and this is going to be, let's just say revolutions per minute. I'm going to use Q, revolutions per minute, RPM, times that numerator was without the 480. Without that 480, 60 and 25 is just 1,500. Okay, and in the denominator, you still have 12 and 5,280. You still have 360.
So for the top portion, we excluded the revolutions, did 60 times 25 times pi, correct?
Right, I didn't put my pi. So I have 1,500 pi, and then I'm using Q times a Q, and this is going to be in the numerator. I have the units RPM, and minutes would still cancel.
Mhm.
Inches would still cancel. Feet would still cancel. I have miles over hours. I still have that though.
Mhm.
So revolutions per minute times miles every hour. And the denominator is still 12 times 5,280 equals 7.
I got lost. How did you get the 1500?
So 1,500 is the 25 times the 60 times a pi. There's a pi here.
25 times 60. Yeah. Oh, okay.
1,500 pi.
Oh, I multiplied the pi with it. That's why.
And that's okay. You have decimals, but here's what's kind of nice. And this is what I do make a big deal about this during the semester. If you're going to have to round your final answer, don't round until the very end. So I'm not going to make a substitution for pi because it's easier to write just 1,500 times pi than that decimal, and then keep working with that long decimal until I make the rest of the moves. And so that's just a little bit of how do you get the most accurate of an answer. So 1,500 divided by 63,000. I'm going to simplify that because I get in that simplifying kind of mode. So when I simplify things, I get this. I get 25 pi over 1,056 times what I'm looking for, Q. Revolutions per minute, and then miles over hours. Equal to, on this side, 70 miles over hours. And because if I go down there to finish working the problem, I'll never get back up, I'm going to rewrite what I have up here. 25 pi over 1,056 Q RPM miles per hour equal to 70 miles every hour. So now, solving for Q, you just need to undo what's being done to it. In the numerator, that's all multiplication. So Q is being multiplied by 25 times pi times revolutions per minute and times miles. Now remember, what I want to know is what does Q equal basically in revolutions per minute. So I want to undo everything except those little pieces right there, the Q and the RPM. So that means I have to divide both sides. I'm going to divide by 25 pi and miles on this side and over here, 25 pi and miles. So this reduces nicely and miles reduce nicely. And all I have left in the numerator is Q times my RPM. It's being divided by 1,056 times hours in the denominator. So to undo the denominator, you're going to multiply both sides by 1,056 and hours. So 1,056 is up here and hours is up here. So that reduces nicely and that reduces nicely. So what you're solving for is how many revolutions per minute does that machine need to spin? in order to make that happen, and over there, we end up with hours reducing, we end up with miles reducing, and we end up with 70 times 1,056 over 25 pi. Don't say. Q is equal to 73,920 over 25 pi. So if I simplify that just a little bit more, if it had to be exact, numerator and denominator, you can reduce a 5. So that would be 14,784 over a 5 pi. And then you go decimal. Go 118.272 RPM. Wait a minute, that isn't that. That's not right. Oh, I did it twice. I messed up my answer. I know. Oh, I see what it is. I can't see because I'm wearing the wrong glasses. I'm wearing the computer glasses so I can read the screen, but I can't see the calculator with those computer glasses on. Life sucks. There. And here's why I knew it was wrong. This is absolutely I know it's wrong. It took 480 revolutions per minute to get a 35 mile per hour test.
Mm-hmm.
That's
so
less.
Yeah.
So this better be more.
Mm-hmm.
And 35 miles per hour, 70 is almost twice. So my answer better be a lot more. And I came up with 941.
Yep. That's what I got too.
Yeah. 0.179. So that's what you need to do when you do a problem, do a word problem like this. Does my answer make any sense? Well, no, it didn't.
Okay. That sounds good.
Well, any other questions?
No, it was just that, like, how do you know when you use 2 pi, but it's based off what you want at the end, what units you want at the end.
And they'll all the curveball is, oh, you want degrees per minute. So now you're using 360 degrees every whatever.
Mm-hmm.
And you're not using 2 pi.
True.
One of the questions I love to ask is, let me see on the homework. I know it was an example that they gave. You'll see it in the review sheet, but in the textbook, let me see, where's my textbook at? Yeah, let me show you in the textbook. I love asking these questions that involve an everyday object in your house, in the, well, definitely in the classroom. And let me do is share it. The clock. You know, the second hand. Okay, which one is the second hand? There's a first hand, a second hand, and a third hand. Which one is it? The second hand is the one that counts out the seconds.
Okay.
I don't know. Is that Mickey's long hand, short hand? Which one is that? No, Mickey. The short one is the hours. The longer one is the minutes. The second one is the one that goes around, a lot faster than the other two, because 60 seconds. I have to explain analog clocks to college students. Okay.
Oh,
But
God.
the length of the second hand is 10.2 centimeters long. What is the linear speed at the tip of that second hand? So you're not given anything else. Now, I would tell you in centimeters per minute or centimeters per hour, what is the rate that is traveling? See, if you don't know what units to give in your answer, then it's a little bit harder to get from one side of the street to the other side of the street. What do I want my answer to look like? So in one revolution, it travels a circumference 2 pi r. And so in one revolution, it goes 20.4 times pi centimeters. So linear speed, distance divided by time. So it's doing 20.4 pi centimeters, okay, in 1 minute. Now, 1 minute lasts 60 seconds long. So if I ask for distance per second, so centimeters per second, then you just put what's the total number centimeters over seconds. And that's how they get, it's traveling at 1.07 centimeters per second. But if I asked you what is the distance in, centimeters per hour, well, then you would convert the seconds into hours. So you multiply by, okay, there's how many seconds in a minute, and then how many minutes in an hour. And I could, I try to ask this question, I can ask it for what's the linear speed of the hour hand, what's the linear speed of the minute hand in units, and I tell you what the units are. Mm-hmm. You can always ask you the angular speed. What's the angular speed of the minute hand? How many angles? And I always have to state in degrees per minute or radians per minute. Mm-hmm. And so if I don't give you what units to look for at the end, I have to grade 15 different possible correct answers because they would work.
Yeah.
That little example question is one that I like, and I put it on the review sheet when that time comes.
Okay. Sounds good. Thank you so much for your help.
Hey, you're welcome. You have a good weekend.
Likewise.
Okay. Bye-bye.